What is a quadratic equation? Well, a quadratic equation is any equation that has the variable raised to the second power. Many students get confused because when they see the second power, they don't think of quad, because quad in most people's mind means 4. You'll just have to get used to the fact that mathematicians refer to quadratic as being raised to the second power. Let's look at our first quadratic equation. We're going to place each in standard form and identify the variable, identify A, B, and C. Now, before we can identify A, B, and C, we have to recall what standard form is. Standard form for a quadratic equation is as follows. It is ax squared plus bx plus c equals 0. Now notice that the variables are in descending order from the highest power to the lowest. Notice also that the equation is set equal to 0. Once you have your equation in this form, this is standard form. So let's identify the values for A, B, and C in our given quadratic equations. Here's the first one. We're going to look at 2x squared plus 12x minus 9 equals 0. Notice that this is exactly in standard form. So the work has been done for us. Our job then is to identify the coefficients A, B, and that constant C. Well, A is the coefficient of the x squared term. So in this case, A is equal to 2. B is the coefficient of the linear term. In this case, we have a 12. So B is equal to 12. And C is just the number by itself, or we refer to that as the constant term. So C is equal to -9. So far, not too bad. Let's look at our second equation. Here we have 7x squared equals 6x minus 8. I'm sure you would agree with me that this equation is not in standard form. For one thing, we do not have 0 on either side of our equation. But we could do that pretty easily. All we have to do is subtract 6x from both sides of the equation, and at the same time, we'll add 8 to both sides to get a 0 on the right-hand side. So here we go. 7x squared. I'm going to subtract 6x from both sides of my equation, minus 6x. I'm going to add 8 to both sides, add 8. And when I do the same operations on the right-hand side, all I get is 0. Exactly what I wanted. Now this equation is considered to be in standard form. Once we have standard form, it's very easy to identify the values of A, B, and C. A is equal to the coefficient of the x squared term. In this case, we have 7. B is the coefficient of the linear term, which happens to be -6. And finally, C is just the constant term, or the number there all by itself. So in this case, C is equal to 8. Now that we've worked a little bit with identifying these quadratic equations and putting them in standard form, let's take a crack at actually solving a quadratic equation. Let's look at our first quadratic equation. We're going to try to solve the following. We're going to solve 2x squared minus 7x minus 6 is equal to 4x minus 6. Now, when solving a quadratic equation, what we're going to want to do first is to write it in standard form, just as we previously did. In this case, we see that we have a 4x minus 6 on the right-hand side. We want the right-hand side of our equation to be equal to 0. So what we're going to do is subtract 4x from both sides of our equation, and at the same time, we'll add 6 to both sides of our equation. So we have the 2x squared up front. Again, we're subtracting 4x from both sides. So negative 4x plus that negative 7x there gives me negative 11x. At the same time, we're going to add 6 to both sides of my equation. Add 6, negative 6 and positive 6, 0. So I don't have a constant term, and that's equal to 0 on the right-hand side. Now that we did this, how are we going to solve this quadratic equation? Well, do you remember the method called factoring? We're going to do it again. What is the GCF of 2x squared and negative 11x? How about x? Inside my parentheses, I have left a 2x minus 11. Now, since we have a product that's equal to 0, we can apply the zero factor property principle. So here we go. If two numbers have a product of 0, either the first one's 0 or my second one's 0. Do you remember that? I'm sure you do. So in this case then, I see one of my possibilities for x is 0. I look at my second equation, and to solve that for x, I'm going to add 11 to both sides. And to solve finally for x, I'm going to divide both sides by 2. So there we have it. We have two possibilities for this quadratic equation. X is either equal to 0 or x is equal to 11 halves. Not too bad, is it? Let's try one last problem. Again, we're solving quadratic equations. So let's see what we have in store for ourselves. We've got 10x plus 18 over x squared plus x minus 2. That's equal to 3x over x plus 2 over x minus 1. That's quite a handful, isn't it? Well, what we're going to do is we notice right away we have our foe, the fraction. Now, most students do not like working with fractions, so we know that as soon as we see an equation involving fractions, we're going to use a method of multiplying the equation by the LCD to clear those fractions. Now, looking at these denominators, it's not easy to identify the LCD because it's not in factored form. So what we're going to do is factor this denominator. Now, you should be an expert at this factoring at this time. Factoring the trinomial x squared plus x minus 2 gives us product, negative 2, sum, positive 1. Now notice these other two are already in factored form. We have the x plus 2, and then finally we have the x minus 1. Now that we've got both sides of the equation here, or all of our fractions, we should say, in factored form, we can easily identify the LCD. Would you agree with me that the LCD in this particular case is x plus 2 times x minus 1? Since that is our LCD, do you remember this procedure? We're going to multiply every term in this equation by that LCD, x plus 2, x minus 1. When we do this on the left-hand side, do you notice that the x plus 2's and the x minus 1's divide out? That leaves us with a 10x plus 18 on the left side of my equation. On the right-hand side, you see that the x plus 2's divide out. That leaves us a 3x times an x minus 1. And similarly, in my last term to the right here, I see that my x minus 1's divide out, and I'm left with 2 times x plus 2. Now look at my original equation up here with all those fractions, and look where we are now. It may be long, but at least we've gotten rid of those fractions. Now I know you're an algebraic expert now, and you recognize that right away when you see those parentheses, you're going to perform the distributive property. So let's distribute. 10x plus 18 equals, using my distributive property, this gives me 3x squared. Distributing here gives me minus 3x. Plus, again, we apply our distributive property. That's going to give me here 2x, and there plus 4. Now we've got a long string, don't we? So what we're going to do then is the following. I see that I have my quadratic term, or that means my term that contains the x squared, on the right-hand side of my equation. So what I'm going to do is collect like terms, and at the same time, because I want to write my equation in standard form, I'm going to subtract 10x and 18 from both sides of my equation. Let's try that. Again, I've got the 3x squared. That's taken care of. I will cross out the terms as we use them so we can keep track of what we haven't subtracted. Now, we're going to do a little mental math, so stick with me here. Negative 3x and positive 2x give me a sum of negative x. You got that? Negative 3x, positive 2x, negative x. Now, I haven't written that down. The reason why I have a negative x here is now I'm going to subtract 10x from both sides. Negative x, subtract 10x more. Are you with me? Negative x minus 10x gives me a negative 11x. That takes care of those. And finally, I see I have a plus 4 here on the far right, but I have an 18 on the left-hand side of my equation. That tells me I want to subtract 18 from both sides. So are you with me? 4 minus 18 gives me a negative 14. Now notice we have a trinomial when the leading coefficient is not 1. So this is the more difficult type of factoring. Now employ any method that you like best, but I'm going to use the trial and error method. I know that my first two terms must be x and x because I have a 3 here. Now I need factors of negative 14 to be placed in these positions so that their sum is negative 11. Well, I'm going to do it this way, negative 14 and then positive 1, and then I'm going to make a little check here. Outside, I get positive 3x. Inside, I get negative 14x. That gives me my negative 11, and sure enough, I have my negative 14. Now that I have a product equal to 0, I can apply the zero factor property. I know that 3x minus 14 equals 0. This first factor equals 0. Or the other factor, x plus 1 equals 0. Since I'm down here and I see that's easy to solve, my first possible solution is x equals negative 1. On the second side here, we're going to add 14 to both sides, and then after that, divide both sides by 3. I'm going to write the solution for x, but I want you to go ahead and take as many steps as you need. So in this case, when I add 14 to both sides and divide by 3, I end up with 14/3. So my two possible solutions here for this quadratic equation is x equals 14/3 or x is equal to negative 1.